conversation today is supposed to be about 5G and how it impacts our security. I think you've all probably heard a lot about that. I spent quite a long time thinking about that. I've actually spent all the way back to 2017. Some of you may know I wrote a controversial report when I was at the White House that got leaked to the media. When it got leaked, I was in the process of briefing the cabinet secretaries. And that was after an extensive study I had done, not with policy experts in Washington, D.C., quite frankly, because I think we need a lot less of that and a lot more of technology and science. And so I talked to people that built networks, Ericsson, Nokia, Samsung, talked to Google engineers. I talked to, from the tech community, I talked to all the LEO space guys, Starlink, OneWeb, a little company called Vector Launch that was working on a constellation called Galactic Sky. I really wanted to understand what 5G was. And so you can find that, all that wonderful research went into a paper and a presentation that I put together. And you can find it on the internet today, the full thing, including the presentation that I briefed to, for example, the Commerce Secretary and the Secretary of Energy and various other cabinet secretaries, and the National Security Advisor, and who at the time was H.R. McMaster. So, the conclusion of that, was this idea of understanding where technology was taking us, what the implications were for us, not just from a commercial perspective, but what did it mean for free countries, free societies, democracies. And the conclusion that I came to, and this was after I had worked on the national security strategy, so you can go see that. That's a 70-page document that I worked on and tried to provide guidance to in terms of how we thought about the future, how we thought about the future of democracy in a digital world, and in a world where globalization existed. And that exists too. So you can go kind of think about the statements that come out of that. It says data is like oil. What does that mean? Data is like oil. We hear that term, but we don't understand. Well, data is what defines people today. It's not, it used to be very much local, what defined you. Where you lived, what school you went to. No longer, we have these devices that go with us everywhere. Everybody in this room has one, and I bet a few of you people have two. Now, what does that mean? Well, it means that because of the free availability of SDK data, that everything that you do is open for anybody to discover and kind of wander through and figure out who you are. Who are you? What do you do? Who do you meet? What do you buy? Where do you work? If you're an executive for Citibank or JP Morgan, what deals is Citibank or JP Morgan contemplating because you're an executive and you're meeting with whoever you're meeting with? Why are you in this room? What do you do after you go into this room? All that stuff is available to the highest bidder who has the time and resources to do it. By the way, some of our adversaries have the time and resources to do it. So it was this context that really led this idea that data is like oil. It's the 21st century version of oil. That led me to really look at if it's a 21st century version of oil, and if we have borders, we can protect our oil from being taken, but we don't have borders in a digital sense. Well, what do we do about it? How do we protect data? This is a fundamental question. It's not just about your company. It's not just about you as a person, the stealing of your identity or the knowing of what you do. Say you have a jilted lover. Maybe they want to know what you're doing. It's not just about those things. It's about sovereignty. It's about political independence. And these ultimately translate back to national security. When you go read the Federalist Papers or understand the Constitution, why did we create a Constitution? It was to promote the common defense. The states, the Federalist Papers writers, believed that the states individually could be attacked, and that all states needed to come together in this republic in order to defend themselves. Okay, that's a physical world. What about a digital world? How do you defend your political independence and sovereignty, right? If if your data is available and everything about you can be known, well then, how can that be used to manipulate your perceptions, intentions, behaviors? Right? Because we all know that's what the FANGs do, the Facebooks, Amazon, Apple, Netflix, Googles of the world. That's why they represent 25% of the S&P 500. It's because of what they do with your data. And that's a very valuable business model. But it's also very valuable if you also want to, have a say or influence the social and political. So these are all important things kind of at a high level. But what do you do about it? We all know about cybersecurity. We all know about, trying to protect our data. And we all know that it's ultimately a useless endeavor, or is it? How do you think about security in a world where literally, this device that you carry in your pocket is in some way, shape, or another built into the fabric of our society as infrastructure? The modem, the antenna, the brains, the operating system, the applications. And each of those locations represent a fundamental vulnerability. How do you protect that data in that kind of a system? If your phone can be disassembled and I spread the parts all around this room and I let whoever or whatever have access to them, how do you protect your data in that context? Pretty difficult, I would say. When I lived in China, I would not even let this thing get out of my hand. Now, that doesn't mean that somebody wasn't getting into this thing, but it's, Apple's done a good job of kind of trying to create a sealed, encrypted environment to protect the data that's inside. But if you lose this thing, all bets are off. So think about that in the context of infrastructure. How do you create something like this, but do it in infrastructure? This is a huge country. It's huge. And these components of what powers our mobile world are spread out everywhere. What if I told you that any cell tower, at the base of the cell tower, has a room where the baseband units are stored, and if you know the 4-digit code, you can go in and touch any of them. And guess what? That's a common room. Right? That's not secured. Now, you may have a Tier 3 data center where your 5G core is located, the brains of your telecom network. But what about the people that work in that Tier 3 data center? What about the people traverse it? And from a government perspective, we put secure computers and systems inside what we call secure compartmented information facilities. What about the people going in and out of there? What happens when you say this room is secure for top secret classified, and the person working in there decides that they want to watch cable TV? And in order for them to watch cable TV in that room, they need to drill a hole through the wall. What have you just done? You've just introduced a vulnerability. So how do you protect our most precious of data from that type of stuff? So when you think of security, it's not enough to think about, we talk about encryption. Let's just start with the basics. The networks that we have today, the telecom networks that we have today, are an amalgamation of various generations of hardware that have been cobbled together because we want to have backwards capability with the later generations, and we want to be the most up to date. So if you look across the landscape today, the only company we have building a network that is, what I would say, has taken care of all of that, what I say, bloat, is Dish. Dish basically said, we're going to build a 5G standalone network. Now, here's the problem. Who has a 5G standalone device? Very few people right now have a 5G standalone device. But Dish is building a network. So what is 5G? Well, one of the things it does that other telecom technologies didn't enable is the ability to have a private network, a private versus a public network. Now that's pretty neat because now you can own where your applications live, where your data lives. You can own all the connection all the way out to the device. So today, in today's kind of environment, what's the equivalent of that? It's a Wi-Fi network in your home. But guess what? The Wi-Fi network in your home will not go anywhere. Once you leave your home, you're out of your private network. Now, everybody has to do their own security on their network, so there's something to be said about that. But ultimately, we don't have the concept of private networks that travel with you, right, that you can take with you. So you own your environment. 5G is a technology that enables you to take that private network with you. So that's a new thing that came out because we took all of this old hardware, and today, cores, by the way, the brains of the network, have basically translated that hardware into software, and they often become very cumbersome, very large volumes of code to make those things work for, like an AT&T. But you can start to pare that down now when you start to think private, right? And you can start to think, you can bring back kind of what we used to be, how we used to be defined, into a more of a local sense. So now your private network can roll with you, and that's something that's very interesting. So then you're thinking, okay, well, now I have my private network, I'm taking it with me. What are other things that I need to think about? What about encryption? We've heard of quantum computing. So there's quantum key distribution, there's quantum communication, and there's post-quantum encryption. And I think if we're worried about the post-quantum world today, what we're worried about is to be able to collect data today and then break that encryption so that you can see the data tomorrow. And the answer to that is something called post-quantum encryption. So you can basically start to think, okay, now I've got a private network. Now I want to apply some post-quantum encryption to enable myself to protect my data inside. What are the other things you need to think about? Resiliency. Okay, do you think the people that were going across the Rocky Mountains as we conquered the West had any concept, or would have any concept, of our connected world today? No concept whatsoever. They hunted, they grew their own food, they could make their own clothes. They were pretty much self-sufficient. Kids growing up today are not self-sufficient. If they don't have one of these, they don't know where to go, they don't know how to get there, they don't know what to eat, they don't know how to pay for things, they don't know how to call for help. It's all based on these. Everything that we do today is based on these. So resiliency means that those things continue to work, even in the most disastrous of situations. Now, I come from the military. I was a B-2 pilot. We had the nuclear mission. Guess what? Our comms always work, even on the worst days, because they're designed that way. But I've always had in the back of my mind, especially after Katrina, what happens if I'm doing that mission to the rest of our country? What are people going to do? They can't communicate. They can't call for help. They can't get medicine. They can't get food. They can't pay for anything. Nothing works. What are they going to do? What would you do? What's your plan if your family becomes separated in that environment? How are you going to communicate? Do they know where to go? Do you think about these things? Probably not. Most people don't. But that's a symptom of the world that we built, a world that is driven by the digital bones of this country that can disappear in an instant. And we've seen that. We saw the Tennessee bombing 2 Christmases ago. E911 mobility gone for Tennessee and surrounding states for 2 weeks. Katrina. There's been other kinds of natural disasters or man-made crises that demonstrate the fragility of our infrastructure, yet, we think that, we're safe. Okay, so resiliency is a pretty important thing, because if that thing doesn't work when you most need it to, that's a problem. Okay, so now you've got the encryption, now you've got the private network, but what if you're what if, like I said, we've spread the parts of your device everywhere and people have access to it? Remember I just mentioned the fact that you can get into any baseband unit room at the base of a cell tower today with a 4-digit code. Plant some device in there. Forget the SDK data I talked about that you can get. I mean, you can just get in there and start mucking around in it. How do you prevent that? What are some tools and technologies? Have we developed stuff like that? Well, it turns out that military actually has. They have things that, allow you to prevent for physical access to devices. Have we adopted any of those standards for commercial infrastructure? Nope. Heaven forbid that we design kind of best practices into the things that protect the most precious resource of the 21st century. We don't do that. So we need to think about that. So if you were going to think about, well, how do we do this for a nation? Like I just said, we've got the device. Pretend this is the United States. We've got the components everywhere, and you can get into any of them as a means of getting into your data. How do you think about that from a national perspective? Well, I think you start to bring it back to the local. How do we take this stuff down and we localize it so that when we have infrastructure, it's resilient and secure at a local level? And then we begin to connect that. So how do you think about that in a world today where I just talked about, the grid can be gone tomorrow, which means the network's gone tomorrow. What does that mean for our society? So, I mean, the way that I think about it, at least, is what are those things that are most important to you? And I'm not saying most important to you as a person, but most important to you as a community, as a city, as a county, as a state, as a federal government. What are those things that you think probably shouldn't go down when everything goes down? Then maybe you start there in terms of how you do things. And finally, I'm just going to take it down to, as you look at this, as you think of securing data in this 21st century and protecting all that is vital, not just to our country, not just to the free world, but to you as an individual, to you as a family, to you as a community, to you as a company. When I looked at it, I took a step back, and we have something in the military called surety. It's not a common term. People don't use the term surety when they talk about things. But we do use that word in the nuclear enterprise, right? What I'm talking about here is nuclear weapons. So I don't think many, if any, Americans worry about the misuse of nuclear weapons in the United States. We've had them for a long time. They don't go boom, even if we have an accident, and we have had accidents. Why? Because of something called surety. And surety really applies to the personnel, the material, and the procedures by which we operate with nuclear weapons, right? A very precious, a very dangerous thing. And that's to ensure the safety, security, and reliability of our nuclear enterprise. So if you begin to take those concepts, personnel, material, procedures, and apply them to data, you can start to say, okay, well, what I'm looking for here is the safety, security, reliability, and accessibility of data. So what about personnel? How do we do that? Well, first of all, if you're going to be assigned that mission, we vet you. We want to make sure that you have the best character traits, that you are stable, and by the way, it doesn't stop when you enter. It is continuous. It's called Personnel Reliability Program. We monitor everybody, and we monitor each other. Why? Because we're touching something very critical. So personnel, both the vetting and then, the watching and then ensuring that the right people are working on the right. And by the way, the Personnel Reliability Program is not punitive in nature. In other words, if you're having a bad day, if you're sick, if you're having a financial difficulty, then you'll just step back from touching those things until you're ready, until you're back 100%, right? Personnel. Material. Every hardware, every software, every single thing that is brought near that is looked at, scrutinized, and you know the provenance from birth to death. Everything. You know who touched it, you know where it came from, because it's so important. And it also has to do with the design of things. Remember, I talked about tamper resistance. You know, how do we protect against somebody having access to it? How do we protect it in the harshest environments? That's the material part. And then finally, procedures. How do we ensure that after everything that we've done, that we make sure that, if anything goes wrong, nothing can go wrong? Well, say, personnel reliability program failed and I'm coming in on a bad day and, worried about my finances, I'm getting a divorce, not in my right mind. There's somebody there with me, watching me when I do my task. So procedures, two-person control, making sure that there's two people there. So even if we think maybe the personnel thing has fallen down or the material thing hasn't worked, we have two people there that are doing critical functions, whether I'm changing or repairing equipment or I'm updating software code. So personnel, material, procedures. So when you put all these things together and you kind of think about all the elements that of a network today and how we protect data in this environment, and by the way, the world that powers these things is not what we're building in 5G right now. That's the world about cameras and machines. And it's a world about a lot more data, and it's a lot more ability to collect data about you. That world is even more perilous, I fear, than the one we currently live in. So the final piece, I'll just say, kind of in terms of thinking about all of this coming together in one system, one of the things that really concerns me and that I've really looked at is this idea that the things that control our networks are riding right alongside down the same paths of the things that of the data that's going through our networks. So the control plane and the data plane is what I'm talking about here. So having an isolation or a physical separation between the control and data plane, I think, is a fundamental architecture thing that kind of brings this whole idea of looking at securing data in a 5G world together in a way that enables you to maybe get there in a way that doesn't cause you to break the bank. We're not talking about billions and billions of dollars here. We're talking about making incremental improvements to our overall security posture in data as a company, as a community, and then slowly knitting this together. So with that, I'm happy to take any questions.
Okay, you're a modest man. Can you talk a little bit about what's going on in Kiev with Sempre? What you guys are doing to support it?
Well, so we don't have the pictures down here. It's not. I wanted it to be up here.
Yeah. Can you put the picture back up? Hold on one sec.
Yeah, there we go. So the transportable is what we're looking to ship to Kiev. Basically, in my analogy of spreading everything out in terms of infrastructure, what we try to do is collapse it and harden it and secure it, and so making, for lack of a better word, an infrastructure device. So a full data center, 5G network that is hardened against the elements and hardened against tamper and hardened for the battlefield. And so what this provides is basically a 5G bubble. And then, how you get out of that bubble is using whatever backhaul that you desire. So, for the guys on the ground in this case, they would have 5G standalone phones that they can use around the battlefield. Now, we've had talk about how do you deal with spectrum in a contested environment. I happen to think that networks in a contested environment in the future are going to be up and operating, and everybody's going to try to use them. So we believe that actually using these networks is going to be the way that wars are fought, but that the way that you are able to be monitored and tracked on that battlefield has to have a barrier between it. You need a border between your device and the cloud. And that barrier is kind of what we're focused on, is creating that environment so locally you can be protected And as you move out of that local environment using backhaul, that what you're doing, who you are, where you're going is not something that's being carried off into the wider world. So thanks for the question. And what we're doing is we're fighting bureaucracy right now.
I think that's always the case. Last night we had a couple of people who have had experience providing bleeding edge technology, and lots of interesting discussions about how to make it so that the innovation happens, and we appreciate all you've done for innovation. On the administrative side, and I don't want to deal with politics per se, but when you're looking at what's needed for the future, where do you think the most issue, how do I put this? Where do you think, well, let me put it the way John Pelson puts it, okay? We have an interesting situation where all our nuclear silos happen to be where small regional carriers are, okay? And it's not necessarily where the best technology is.
Right.
So how do we sit there and kind of restructure ourselves and think about where we're going in the future?
Well, funny enough, the reason my paper got leaked was because there was a very controversial idea in there, this idea that the networks would share the RAN resources, right? Today, we build networks where each of the networks builds their own network, in which case they have a toll road that they don't share amongst each other, and then they compete on those toll roads, the quality of those toll roads. What 5G enables you to do is open that up and really share that and create a superhighway that then can be shared. What this means from a cost perspective, that rather than having to build and buy radios and antennas for 3 networks, you build them for 1. And then what it means in terms of capacity or bandwidth or throughput is that the customer sees the superhighway and not the toll road. And so you have a lower cost and you have a higher performance. That's what 5G enables you to do. But because of the way that we think about competing, that was a very controversial subject. I am getting the sense that we are turning the corner on that. We have too much infrastructure to build, too much cost, and if we compete on that as networks, they are never going to get built. But if we can start to think about sharing the resources, then that would be good. So from a policy perspective, what does that mean? Well, it means that FCC needs to open up the aperture on terms of software-defined radios and how many bands they can cover. What's filtered out? Because today we build radios for those toll roads, right? So we've aligned our policy with our business, with our business models, and they have, from a local perspective, it means that you're very limited in terms of what you can do, right? Because you have to load all this, gear up on a tower in order to get the full, benefit of spectrum that's owned by the American people. And so I get the feeling that is starting to soften. If that softens, you're really going to see an evolution in radio access technology, because it's going to really allow us to be more involved in the software. The other thing is edge compute. 5G is nothing without edge compute. Forget about the word 5G if the next thing that doesn't come out of your mouth is edge compute, because it makes no sense. 5G on a phone does not make any sense. 5G with a camera, 5G with a device, 5G with a machine makes a lot of sense. But the next thing out of your mouth better be edge compute, because the applications that are running need to run there, not 100 or 1,000 miles away. So how do we do that? What's the killer app? That's the problem we're facing with. I happen to believe the killer app is the core. Why? Because we can have private networks locally. But, ultimately, we've got a infrastructure problem in that how do we get edge compute built, right? And then we've got a radio access problem in that how do we begin to open up, from a policy perspective, these things and bring them together in a new way of looking at the world. I don't know of any country that's doing this yet. And that's what my paper said. We needed to think differently about the next evolution of infrastructure and technology if we really wanted to embrace the future. AI and autonomy doesn't mean anything. Does not mean a damn thing if you don't build the infrastructure in the right way. It will not support it. It cannot support it.